All right, this is Mr. McCord's chemistry class, Unit 9, Lab number 1, determining molarity. When we prepare a solution, the molarity is not hard to find as long as you can calculate the number of moles of solid or liquid, whatever substance you're using, that you're going to dissolve in a certain volume of liquid. If we're using something like a volumetric flask, this makes it very easy for us because it has a special mark that tells us exactly where, say, 250 milliliters, or in this case, 1,000 milliliters of solution would be. So this is a 1-liter flask. If we know how many moles of solid or whatever substance we're putting in, we just divide that by the amount of liters of this total solution that we're going to make. We fill it up to that line. But if you're dealing with a solution that has already been made, it's a lot harder to determine the molarity. You may perform a reaction and use up all of the chemical that is dissolved in the water, see how much product you make, and then use that to determine how much was originally in your solution. If it is able to undissolve, you're able to precipitate it out of the solution. That could be another option, or filter it somehow. But in some cases, even that doesn't work out too well. With something like salt, sodium chloride, NaCl, however you want to call it, NaCl is not very reactive, so it's hard to find a reaction that's going to tell us how much NaCl was originally in the solution. It also passes through filters because it dissolves very well in water, so we can't just kind of sift it out of there. So we have to get crafty with this. In order to figure out the molarity of a salt solution like this, we can boil off the water that it's dissolved in, leaving only the salt that is not going to boil at this temperature. It's not even going to melt, not even close. So we wind up with some solid left over in a known amount of volume of solution that we started with. So this experiment is a little bit more freeform than others because we don't have a set amount of chemicals that we need to use. We don't have a set procedure. We're going to kind of figure it out as we go. So we have some solution of unknown molarity of NaCl dissolved in water here. Okay. My goal is to boil off the water to leave only the salt behind. So if my end goal is to figure out the molarity, that should be moles of my solute, which in this case is the salt, the stuff being dissolved, divided by the liters of solution, which I can determine. In this case, I'm going to use about 50 milliliters, just so I've got enough to have a substantial amount to measure in the lab. I don't want to use so small that I can barely tell how much is there, or the scale has a hard time reading it. But I also want to have not so much that it takes a really long time to boil off my water. Now, I could use something like a beaker. Beakers are pretty standard, they're temperature resistant, they're kind of our catch-all for lab glassware. But as I boil off this water, I'm going to have a lot of bubbling, and as soon as I start getting this solute to undissolve from the water, as I run the water out, as I boil it off, I can get some popping and things can start flying out. It's going to be hot. So instead, I'm going to be using an Erlenmeyer flask, or a conical flask, so that way I've got some kind of coverage here that will keep stuff from spitting out at me as the solution boils inside here. Now, I'm going to need to heat this up somehow, so I could use a hot plate, but I'm a little too impatient for that. We're going to use something a little bit faster, can run a little bit hotter at the rate that we want it. We're going to be using a Bunsen burner. Right? So if I want to heat this up using a Bunsen burner, I can't just set it on top of here and kind of hope it balances, because then I'm going to block the gas flow. I'm not going to have a flame. I could try and clamp it above with a rod and a clamp, but that's not super safe either. I'm going to have to grab it at some point. I don't want it to, just have to wait forever to cool off. So that's not too good either. The best way to do this is to have a platform for this to rest on that a flame can still heat through. So we've got a ring that can attach to a ring stand. All right. My flask is smaller than this ring, so I won't be able to just lay this out here and set the flask on top because it's going to pass right through. So to give it something for the flask to rest on, we've got a wire screen. All right. see through it. Flames and heat can go through this, and it conducts well because it's made of metal. It's not going to melt on us or get deformed in any way. So I can set my flask on top of the wire screen, which is on top of this ring that I can attach to a ring stand to hold above my Bunsen burner. This is not the only way that you can do this. You can, of course, use a hot plate. You could use a different setup rather than a ring. Some stands have a kind of triangle that you can place things on. We don't even have to use an Erlenmeyer flask. But in this case, it kind of fits our experiment best to be safe and practical and efficient. So if I can measure out my original volume of solution of some unknown molarity, some unknown concentration, and transfer it into this flask, I know the liters of solution that I'm starting with. If I want to calculate the molarity, I want to know the moles of salt in that volume, that liters of solution. So I need to boil off the water, see how much salt is left. I will measure it in grams. Okay, so I'll need to subtract out the mass of the original flask compared to the salt that is now added in there. Once I have grams of salt, I can convert that into moles. Moles divided by my liters of solution is going to be my molarity. All right, I've measured out about 47.1 milliliters of solution. Keep in mind that for molarity, we need liters of solution, so I would need to convert that from milliliters into liters. I'm going to transfer it into my flask, which will handle itself much better on our Bunsen burner. Start up our flame. I want it hot, so we don't have to wait forever, but I also don't want it super hot. You can see already it's starting to get red from the heat. You can see where most of the heat is coming through, so I can try and position that where my flask is going to be sitting. Not heating more on one side or the other. That's pretty good right there. Flask on there. You can already see the sides are starting to fog up as the water's going to start evaporating faster. It'll start condensing on the cooler parts of the glass up top, but eventually it's going to clear up a little bit as it gets too hot for our liquid water to condense back from the gas phase. Once we run low on the water in our solution, we should get some salt popping out, which is again why we're picking kind of a cone-shaped flask to protect us from salt popping out. I might also turn down the flame so that way I don't have too much popping. Otherwise, I could have salt flying out of my flask and therefore not showing up in my measurements, which is kind of the point of all of this. Okay, once all of our water is boiled off, we can measure the mass of the flask and the salt together. If we subtract the mass of the flask, we're left with the mass of the salt, the NaCl. Once we've got that mass of salt in grams, we can convert that into moles, which can then be used to calculate the molarity. Moles of NaCl divided by liters of solution that we started with, 47.1 milliliters converted into liters, can get us our molarity.